as a review, and I know you guys just did your levels for last class, so we did already kind of review this, but to go over it one more time, we learned about the trigonometric or trig ratios of sine, cosine, and tangent. When you are doing sine, or you are using sine when you want to either know something about the opposite or the hypotenuse, because that is the ratio for sine. For cosine, it is the adjacent leg divided by your hypotenuse. And for tangent, it would be the opposite over the adjacent. That is the SOHCAHTOA rules we learned about last class. Again, I have it here for you on your notes. It's on the orange reference sheet in the middle of your table, so you have plenty of ways to see that. Again, sine is opposite over hypotenuse, that's so. And then ka is adjacent over hypotenuse. And then toa is opposite over adjacent. If I were going to put a focus on something, again, from last class, this is what we really did, is recognize the ratios for SOHCAHTOA, which is our 3 basic trig functions. Then we have an example here for you. Again, it's completely worked, so you can see how we did these problems. You all just did these on the boards with your levels, so for the most part, we remember. One thing I want to remind you is when you're solving these, a lot of you notice the pattern that if the variable you're solving for is in the denominator, you're going to divide the other side length and the trig function. If the variable you want to solve for is in the numerator, that's the ones where you would multiply the numbers together. So denominator divide, numerator multiply. Or just solve it like a proportion like we did, and you don't have to remember that trick. What we're doing today is we're looking at the inverse version of sine, cosine, and tangent. These are called inverse functions. Now this makes sense to us because we've learned about inverse operations for basically our whole life. Thinking like addition, what is the inverse of addition? Subtraction. What is the inverse of multiplication? Division. So sine, cosine, and tangent are operations just like addition and subtraction. So we need to have an inverse for each of those functions. The inverse for sine is literally called inverse sine. Isn't that nice? We just named it the inverse of sine. The inverse of cosine is called inverse cosine. And the inverse of tangent is called inverse tangent. But we represent them on our paper with the little exponent of -1 to show us that we're doing the inverse. If you Google stuff on the internet and you see something called arc sine, arc cosine, and arc tangent, those are the exact same things. It's just another way to represent this. So when we are doing inverse functions, instead of putting in an angle to get out a side length, you are going to find the angles. If you notice, all 3 of these equations say the angle is equal to something. So now this class, we can figure out what the missing angles are if we're given 2 sides. Last time we used the angle to find the missing side, so now we're just working backwards. We're working in a different way. So before I show you an example, just some cautions for you. Number 1, make sure you remembered to put your calculator in degree. I didn't really see anybody struggle with that on our levels. That means we remembered. You are my first period class, and my 8th period class works in radians. So you specifically have to make sure you change this calculator to degree because it will not be in degree when you show up to class. So we change it to degree every time. Anytime you pick up a calculator, you make sure it's in degree now. To type in the inverse functions, instead of just typing sine, cosine, or tangent, you're actually going to press the blue button second before you type tangent, cosine, or sine. If you notice on your calculator, what's above sine, cosine, and tangent that's blue? Right above the button for sine, cosine, and tangent, what do you see? No, sorry, in blue. Right above sine in blue, I see sine to the -1. That's inverse sine. So if I'm trying to calculate inverse sine on my calculator, I will press the blue button and then sine to make it inverse sine. So when we're typing in our calculator, if we're doing inverse tangent, we would do second tangent and then the opposite over the adjacent. If I was doing cosine, I would do second cosine and then enter in the side lengths, the adjacent over the hypotenuse. For sine, it's the opposite over the hypotenuse. So it's the same ratios from last class, still SOHCAHTOA. This time we're just doing the inverse function because we're finding the angle. Now again, I highly recommend you download that Calculate 84 app on your phone for this because you can do this on Desmos. Typo, that should say Desmos. But it's a little bit more tricky to find everything. So if you use Desmos at home, I'll show you separately how to find all of these things, but I highly recommend using a yellow calculator. So let's practice this. We're going to use our calculator to find the value of theta to the nearest tenth. That means we're saving 1 decimal. Well, right now it says sine of theta equal to 17 over 40. I want this angle theta. Remember, that's not a 0. I got a lot of questions about that throughout the last few days. That's not a 0. It is a Greek letter called theta. It represents the angle. If I want to know what that angle is equal to, I want theta to be all the way by itself. To get theta to be by itself, I need that sin for sine to go away. The only way that I can make sine go away is if I do inverse sine. But what I do to one side, I have to do to the other. So I'm going to take the inverse sine of both sides so that in my calculator, I'm typing in inverse sine of 17 over 40. So again, if I want the theta by itself, I just do inverse sine to the other side, whatever's over there. So in our calculators, we're literally just going to type this in, and our answer will round to the nearest tenth. Now that we've turned to our calculator and seen how to type that in, we know that this angle theta is equal to 25.2 degrees. Anytime you answer with a theta for me, there should be a degree symbol behind that number because we're answering with an angle measurement or a theta. Questions about that? Can you guys finish number 2 and 3 for me? I want to find the theta or the angle that makes these equations true. So for number 2, your answer should say theta equal to something. And for number 3, it should say capital Y equal to something, since that's the letter that they used. I'm going to stop talking. I'm going to let you type in your calculator. Let's make sure we know how to solve this. When I'm doing the middle number 2, this time, instead of putting inverse sine, did you put inverse cosine on both sides? Because I want to get the cosine to go away, so I do inverse cosine. That right there is just something I can chunk into my calculator. You press second cosine, 0.9613, enter, close parentheses, enter, and you should get, rounding this to the nearest tenth, and this is a weird rounding, I think it's like 15.99, which would actually round to 16.0 degrees. Did we use inverse cosine? I'm seeing lots of inverse cosines on papers. That's great. For the last one, because it says tangent, to get the y out of tangent, to get that angle, I'm going to do inverse tangent on both sides. So in my calculator, all I have to calculate is second tangent, 163 divided by 20. And you don't have to use the fancy fraction here, by the way. It's not super helpful. We should get that that angle y is equal to 83.0 degrees when you round it to the nearest tenth. How did we do on those two? Good? Okay, so that's just kind of using these inverse functions in our calculator, make sure we know how to actually calculate them, and let's apply it to the kinds of questions I'm going to ask you about today. Let's apply it to some triangles. Now, last class, when I gave you problems that looked like these 3 at the bottom, there was a missing side length, so x was on one of the sides. This time, the x is not on a side. I actually have 2 side lengths. I want to know the angle measurement. So we're going to still do exactly what we did last time, but when we set up our equation, our solving step is going to be different. So in this problem, we want to know angle F, which is right here. For ease and to get y'all used to that symbol, I'm going to put theta, which is specifically, it looks like a 0 with a flat line through it. Don't make it diagonal, don't make it up and down, it is flat. Those are all different symbols mathematically. We want to figure out that angle. Well, compared to that angle, what sides do we know? Do we know the opposite, the adjacent, or the hypotenuse? What's this one with the 13 on it? That's for sure the hypotenuse. Okay, so if I know the hypotenuse, what else do I know? I know the adjacent. If I know the opposite and I know the adjacent, which of my 3 trig functions from SOHCAHTOA do I use if I know the adjacent and the hypotenuse? Cosine. So if I set up my equation, I'm going to say cosine of angle theta would be equal to the adjacent, which is 5, over the hypotenuse, which is 13. That's the same setup we did last class. There's just no angle number. Today, now that we've learned about inverse functions, we can actually find that angle. So just like we did on the problems up there, what do I do to get the cosine to go away? Inverse cosine. So to solve for theta, I'm going to say theta is equal to inverse cosine of that fraction we got, adjacent over hypotenuse. Well, that's a calculator moment. So we press second cosine, 5 divided by 13. This problem wants us to round to the nearest degree or integer. So we're going to go to whole numbers only. When you type cosine inverse of 5 divided by 13 in your calculator, what do you get? Somebody's typed it in. What did you get? 67 degrees. Very good. So 67 degrees is the angle of theta. So to answer the question up here, angle F is equal to 67 degrees. So it's like the problems from last class, but we're not solving for a side, we're solving for the angles. But we're still using trigonometry to do it. We'll still do number 5 together, and I think I'm going to have you guys try number 6. On number 5, what angle am I looking for? Which one is it asking me for? R. So on angle R, the one labeled R, that's where I'm going to put theta so that I know what angle I'm looking at. Okay, compared to theta, what sides do we know? Do we know the hypotenuse? No. So do we know the opposite? This is going to be the opposite. And what else do we know? The adjacent. Which of my trig functions uses the opposite and the adjacent? Tangent. So when we set this one up, we're going to say the tangent of my angle is equal to the opposite side length over the adjacent side length. To get tangent to go away so that it says theta equals, what am I doing on both sides? Inverse tangent. Very good. So my equation should say theta equal to tangent inverse, and then you stick that fraction in there, 12 divided by 5. Turn to your calculator and you evaluate this function for me. What did you get when you typed that in the calculator?
67.
67 degrees. Is that right? I actually don't remember. Yep. Now, of course, the answer is not always 67. I know we just had 2 in a row where it says the measure of the angle is 67 degrees. That's honestly just because these are the same triangle flipped over. So we actually found the same type of angle twice. This is a 5, 12, 13 Pythagorean triple triangle. But I think we're ready to try one on our own. I will help you just label your triangle, and then you're going to finish the problem for me. In number 6, which angle am I looking for? G. So that's right here. That means I put theta in that corner. Now I'm helping you label only. So compared to G, what sides of this triangle do we know? Do we know the hypotenuse? Oh, for sure. What else do we know? The opposite side. It's not touching my angle theta, so that's my opposite side. I'm going to leave you here. I want you to finish this problem. So set up your trig function. Solve for theta, round to the nearest degree. I'm going to start working this one quietly on the board because I see a lot of us are finished, so you can check your work. When we're setting this one up, we should have picked sine. Did we all pick sine to use? Opposite and hypotenuse is the part of SOHCAHTOA, which is sine. So I do 72 divided by 97 because that's the opposite over the hypotenuse. To solve for theta, you just do the inverse sine of both sides, and that gives me something I can throw into a calculator. When I do that, inverse sine, so second sine, 72 over 97, and then round to the nearest whole number, this should be 50 degrees. So we know that angle G is equal to 50 degrees. These are the types of problems I'm going to have you do today. Okay? Are there any questions about these three types of problems, numbers 4, 5, and 6? Not yet, right? Maybe when we start trying some problems, we'll have questions? Yes?
I put it in my calculator.
It should be... Oh, wow. Did everybody else also get 48 degrees?
Yeah.
Oh, y'all should have stopped me when I'm doing something crazy. I probably didn't have my calculator when I did this in radians. This should be 48 degrees. Y'all got to stop me when I'm crazy. Thank you, Kate. So this should be 48 degrees. My bad. I would say that's a Monday problem, but it is definitely Wednesday. Oops. Now that I haven't messed up, does anybody have any questions? Okay, if you notice on the back of this, I've actually done the entire back of this worksheet for you because these types of problems, numbers 7, 8, and 9, are really more advanced than I want you to be able to do for my class this year. But if you are planning to go to any of the advanced math classes next year, so pre-calculus, AP pre-calculus, or dual credit, this is definitely the type of question you're going to need to get used to. So I'm going to walk you through one of them, number 8, and I'm going to let you just have a chance to look at the rest of them. So you have a nice set of notes if you keep your notes for when you get to those classes next year. What this problem is asking you is it's asking you to solve the right triangle here, which means find all the missing stuff. Right now on this triangle, what I can see is that I know that this is 90 degrees. I know that this side right here, and I'm just using random colors, this side right here is 3. This side right here is 2. So the things I'm missing are 2 angles and 1 more side. So if you look number 1, if I'm given 2 sides, I can find the missing side with Pythagorean theorem, which is what I've done right there. So we found the missing side length C using Pythagorean theorem. This is from Unit 9, Day 1 notes, if you wanted to look back at that. And then once we have that missing side length, square root of 13, we're then able to use inverse trigonometry to find the angle A, and to find, eventually, we'll use that angle A. You can follow what I did. I used tangent inverse. And once I have angle A and angle C, which I do have, that's my 90-degree angle, I can use the fact that triangles completely add up to 180 degrees to find that angle B. So if you follow through my work, you can see I've used a lot of geometry here, and I love this problem. I think it's really fun, but it's beyond what I need you to be able to do today. Since we had all of those snow days and random testing days, we're not going as deep as we would previously. I just need you to be able to do regular inverse trig like we did on the front. But if you're curious about these kinds of questions, because this is the level that advanced math goes to, I now have 2 nice, neat examples for you to look at to see the different steps you can take. So don't lose these notes. These would be super helpful for you in the future when you take those classes. Yes? Now I know I just kind of talked at you through the back and I just did all the problems for you. They're just there as a reference. What I really need you to be able to do is the things from the front page. So flip back over to questions number 4, 5, and 6. Are there any questions about 4, 5, and 6 before we move on? I'm seeing heads shaking no. So that means that you're going to have the rest of the class period to work on that worksheet for today. So you already have your homework in front of you. You can work through all of the problems. The beginning of that homework asks you to use inverse trig to find angles, but then it's going to switch and ask you to find sides. When you're finding a side, you use regular trig. When you're finding an angle, you use inverse trig.